This lesson is on radical equations, and we're just going to go over the basics of how to solve those. So starting with example 1, I have the square root of x plus 3 equals 7. You always want to try to get that square root or the radical, whatever it is, by itself first. So I'm going to subtract the 3, and that's going to give me the square root of x equals 4. And then to get rid of a square root, you have to square both sides. When you do that, I like to put that in parentheses so that I don't mess up any signs that I have. On this left side, our square root and our square are going to cancel, and that's just going to leave me with x because they're inverses of each other. And then 4 squared is 16. And then the last thing that you want to do is kind of check your answer in your mind and make sure that if you plugged it back into the original equation that you would not get a negative under a square root, because that would give you an I. So obviously if I plug positive 16 back in and it's just an x under there, I would have the square root of 16 when there's no problem with that. So this is our answer. Now for example 2, you don't see a radical, and I believe I've mistyped. This one is supposed to be a 1/2, so let's change that. And we're going to start by making that a radical, because a 1/2 power means it's a square root. Now, when you get to this piece, the 1/2 applies to the y. It does not apply to the 3 because it's not in parentheses. Had the 3y been in parentheses, yes, it would apply to both of them. But in this case, it just applies to the y. So you want to rewrite that and have it just as a square root over the y. Then you go about getting that square root by itself again. So I'm going to subtract the 18 from both sides, which would give me a 7. And then I'm going to divide by -3. So I'm going to get the square root of y equals the -7/3. This is one of those cases when I square both sides, I want to use a parenthesis. So square both sides, make sure you get the -7/3 in parentheses. Because square root and square cancel, that leaves you with y. If you don't have it in parentheses, it's going to mess your signs up, because here you're really multiplying a negative times a negative, and you should get a positive answer. So -7 times -7 is a positive 49. 3 times 3 is 9. So our answer is 49/9. And again, I want to check. If I plug that back in, I don't have a negative under a square root. I don't have to actually, work it out again. I just want to check that I don't have a negative, and so this is fine. And looking at example 3, this is another typo that I've made. This is supposed to be a 1/3. I probably just switched those two when I was typing. So 1/3 you want to be able to work with as well, because that is a cube root. Now that applies to everything in this parentheses. So I'm going to start by rewriting this problem as 4 minus the cube root of 1 minus 7x. So rewrite it as the radical. Then I want to get that radical by itself. So I'm going to subtract the 4, because the 4 is positive. I have to do the opposite. The negative is still there because it goes with the root at the moment. And 0 minus 4 is -4. Now I'm going to divide by that negative, because technically it's -1 times that radical. So divide by -1. The negatives will cancel out on this side. I have the cube root of 1 minus 7x, and over here I have a positive 4. Now the way to get rid of a cube root is by using its inverse, which is cube. So I'm going to cube both sides. And again, I'm still going to use parentheses to make sure I get everything with the correct signs the way that I want it. The cube root and the cube cancel, and I have 1 minus 7x. And then 4 cubed is 64. And I'm just down to a regular equation. So I'm going to subtract 1 and get -7x equals 63. and then if I divide by -7, I get x to be -9. Now, I don't have to worry about plugging back in here because I can take the cube root of a negative number, so this is my answer. I only have to worry about checking it with square roots. And our last example, number 4, looks a little bit weird. I have a square root equal to a square root. They're both basically already by themselves, so they don't have anything added or subtracted on the ends. And in this case, it really wouldn't matter. I would have to do something anyway. So I can go ahead and square both sides. And that will cancel my square root and my square. So I have 3x minus 2 equals x minus 4. And I'm just going to solve that. So I'm going to subtract x and get 2x minus 2 equals -4. And I'm going to add 2. So 2x will equal -2, divide, and x equals -1. Since we have square roots, again, I want to go back and I want to check and see if it would give me a negative. If I plug -1 in, then I have 3 times -1 minus 2, so that'll be a -5. And over here I have the -1 minus 4 will be a -5. I'm getting negatives under square roots. So those would give me i's. Technically, they would give me the square root of -5 equals the square root of -5, which is true. A lot of times, and so that makes this answer okay. Had it not worked out that way, if I had had like the square root of -5 equals the square root of 7, that would not work out, and I would have to throw that answer out. If up here at the top, so that I can explain this a little bit further, if we go back to example 1, let's say that I had gotten a -16. I didn't, but let's say that I had. That would be the square root of -16 plus 3 equals 7. Well, the square root of -16 is 4i, which we're going to get into later. And 4i plus 3 is not equal to 7. And so that's why -16 would not be an answer. It would be called an extraneous solution. But in example 4, we're okay because we got this as the same thing on each side, and it would be I square root 5 equal to I square root 5, and that is okay because we didn't have an I equal to something that didn't have an I. So those are the two different situations. And that concludes this part of this lesson.